So we are done with this. We go to B2, okay, where we have an exponential distribution. So remember what I said, you have to know the formulas, okay? So here they're saying, okay, they're saying a hospital experiences congestion during normal working hours, okay? A patient may spend a lot of time to explain his or her illness. The time taken by a patient to explain his or her illness is exponentially distributed. This is the most important thing here, with an average of what? 12 minutes. So it means the mu or the mean there is what? 12. The patient, okay? So they're saying now, the patient who take within 25% durations to explain his or her condition is considered normal. And then the question now comes, estimate one whole number, the maximum normal time taken by a patient to explain his what? Illness. Okay, so this percent that we've been given here is the probability. Okay, so the probability that a patient, okay, will explain his illness within a normal time is 25%. That's what they mean. So now you have to be delighted with two formulas here. One, okay, for the PDF of the exponential distribution. Two, for the CDF of the exponential distribution. Because we are going to use the CDF to find the what? The answer here. So, okay, so the mean is 12, the probability is 12, is 25%. I mean, okay, so my mu will be equals to what? 12. And then the probability, okay, that x is less than some number here that we want to find, okay, which is the maximum number. So let's say small letter x is equals to what? 25%. And you know that 25% just divided by 100 is 0.5. So this is what we have. But now let's look at the formulas. So the f of x here, let me write the small letter f here. So the probability density function of the PDF of the exponential distribution is given by what? Okay, is given by this formula. Okay, so I was saying the PDF for the exponential distribution is just given by this formula. You have lambda, the power e, okay? I mean lambda multiplied by e to the power minus lambda x. Okay, so this is the PDF. And then the CDF, which we are going to use, is just equals to 1 minus e, okay, to the power minus lambda x. Okay, so now how do we find this lambda here? So lambda is equals to 1 over what? The mu. So the mu here is the 12. So we've been given that the probability of the big X being less than or equal to the smaller x is equals to what? 0.5. So now they want us to find this x here, which is the maximum value. Okay. So how are we going to do? We know that this guy here is the same as this f of x. So we're going to say f of x is equals to what? 0.25. Okay, so let's find the lambda here. Lambda will just be 1 over 12. So our f of x, we are going to replace now with this, and then we equate to this. Okay, so we're going to say 1 minus e to the power lambda x is equals to what? 0.5. So we know the value of this lambda. We want to find this x. So we're going to say 1 minus e to the power 1 over 12, then x. Okay, is equals to 0.5. Okay, so let's take this guy to the other side and then bring this guy to the other side. So we're going to have a positive e to the power minus 1 over 12x is equals to 1 minus 0.25. Okay, and then from there, we can do the substitution here. We're going to find 0.75. So e to the power minus 1 over 12x is equals to 0.75. Okay, and then we apply the log here, the natural log. It means this power here is going to drop. So we are going to have minus 1 over 12 x, and then ln E is equals to ln 0.75. Okay, so this should be ln like this. So that's the situation that we have here. And when we want to find this x, we know that ln E here is always a 1. So this is just a 1. Okay, so we want to find x. So what are we going to do? Okay, we are going to say x is just equals to, so we divide both sides by minus 1 over 12. We are going to have ln 0.25 divided by minus 1 over 12. So this will be the same as minus 12 ln 0.75. Okay, so just get your calculator and then you punch this value here. Okay, so after punching the value, I'm getting 3.45218069. So you don't off this, so you're going to say x. Okay, the maximum minutes is just 3 minutes. Okay, so that's how we find the x there. And then we move to the other question. Okay,